All right, let's kind of review this quickly here. So you should have read through the packet with your partner, or in your case, you guys almost all had your own packet. We're going to collect these packets at the end. So define each term. What did you get for the mean? Trinity. Okay, let's dig a little deeper there. Average is a good start. It's a very good start. Logan.
The average of a data set.
There we go. So we have the mean is the average of a data set. Okay. Absolute. What did we get here for absolute, Chase?
The distance from 0.
Okay, that's absolute value. The distance from 0 is considered absolute value. That's basically what it is. So you're looking at, it's the positive amount or value. So if I have a subtraction that's like 10 minus 20, we know that would equal negative 10. But in absolute terms, where I have these two lines, that is actually going to equal positive 10. Okay, so absolute basically takes any difference and turns it into positive. Okay, Logan.
Why?
Because it's the absolute from 0, or the absolute form of that number. And the positive form is considered the absolute form. Does that make sense? Deviation. This is probably a new term. Cody. The distance, it is. So deviation is the distance from a value. So distance from a value. And in the case when we're using MAD, what's the distance from? Jessica? The mean. So the deviation is the distance from the mean. And the absolute is the positive form of that distance, whether it's negative, if it is negative. How do I find the MAD? So what's my first step here? Step 1. I didn't leave myself much room here, did I? I think. Oh, I know why, because I added stuff into there, so it just left me no room. Eric.
Find the mean of the membership.
So we're going to calculate the mean.
Oh man, I broke the whole mean process.
From, and you can write the whole mean process. That should be a process that we're pretty competent at now. But you could, absolutely. Calculate the mean from the data set. So step 1, step 2. Raul, step 2.
Subtract the mean by each of the numbers in the data set.
Yeah, so whoops, that wasn't what I wanted, but we'll do it anyway. So what happens when you don't give yourself enough room? Everyone loves that sound.
Especially
It's such a beautiful sound. So we're going to subtract. We're going to subtract the values in the data set from the mean. And there's one piece I should put in there. What happens if that value comes up to be negative? Chase.
it has to be a positive number at the end, so you can switch.
So we're just going to put absolute at the end of this. We know that it has to be the absolute value, positive value of that difference. And then the third and final step, Grace. So I basically find the mean of all of the absolute values. Okay, so last step, find the mean of the absolute values. I mean, basically what we're doing when we're figuring out the mean absolute deviation is we're basically doing the mean twice. So that is how you find the MAD. Questions about the MAD? We're good there? Moving on, can you collect the MAD packets? Hand back, you MAD packet.
Hey, that's
The dog ate my homework. Did you know I have a dolphin?
What if I tell Mrs. Fisher on my homework?
Well, in that case, I better hand back your. There we go. Now,
Just keep it you to see if
No.
the other classes catch it.
there's no evidence. No evidence. I'm squeaky clean for Mrs. Fisher.
My dog doesn't eat my homework, my dolphin does.
She has an actual
I do
dolphin.
actually have a
That's cool.
No, wait, you gotta.
You right now. You have an actual dolphin.
Yes.
Where?
Sure. No, I'm not even kidding.
My 54 subscribers now.
We do have it.
Like it's one of those
You got.
Yeah, like I adopted it.
I like your video.
All right. So hey, I want to talk to you guys. So the MAD. If I have,
It was a present.
if I calculate
I have one now.
a mean, let's say I have a mean and the mean equals 18. And I have a MAD that's 6.5. That's 6.5. What does that 6.5 mean? Yeah.
So it means that there's usually a deviation by 6.5.
So there's a deviation of 6.5 greater, and there's a deviation of 6.5 less.
Yeah.
So basically I would do 18 minus 6.5 to get my 11.5 on one side. And then on the other side, I would do the 18 plus 6.5, where I get my 24.5. So now I have this spread, because this is a plus or minus deviation. Yeah, I'm going to be handing them back once I finish up this. So we have that spread. Okay. This is really important to understand, because if I have a data set that's in this spread or outside the spread, I can figure things out. And so we're going to look at a data set right now. So a line plot, which is what I have up here, is another way to show data. Yesterday we looked at, or the day before we looked at graphs, right? We looked at a line graph and we said, oh yeah, we can show data sets with line graphs, and that gives us information. A line plot also gives us information. So here I already have some of this data on the line plot. I have the 6th grade on there, the 7th grade on there, and the 8th grade on there. I'm going to add the 9th grade. So I look at the 9th grade data, and I have a 33, so I'm going to go to my 33, add a dot. I go to my 28, add a dot, and go to my 29, and add a dot. So now I have my whole entire data set on my line plot. You're going to be asked to make line plots today. I'm going to give you a sheet that has the scales on it, and on the back side it has questions, and I'll show you that in a second. So this line plot, what can we say? What can we say about the distribution of the line plot in terms of mean, median, MAD, and range? And we'll even put up here mode. So talk to your partner. Talk to your partner. What can we say about this line plot? And you can share more than 2 ideas around those things. Go, talk to your partner. got it? Okay. So what can I say? What's one that sticks out really easy here? Mode. Okay. What's the mode?
29.
So we know that our mode's 29. That's one thing I could say about this data set, this distribution that I have up here. Corwin, what's another thing?
Range is 29.
Okay.
Wait, no, not median.
The median. Now, the median is 29 because when I do this, I'm left with 29. So we know that 29 is our median. Okay? That's a good one. That data set or line plot gives you that. Xander, what else can we say about it?
Say that the range is like 7.
Range is 7. How'd you get the range?
Subtract the highest one from the lowest. Subtract the lowest from the highest.
So we have the highest is 33. So we minus 26. So we get a range of 7. Okay? Can we look at this and calculate the mean pretty easily, or do we have to do some work? You could kind of guesstimate because you know it's going to be close to what number? 29. It's going to be really close to 29 because we know that our measures of center are not always equal, but they are usually close when we have a data set. So can you calculate the MAD?
There's going to be about 4 because there's 8 numbers.
So if I told you the mean of this data set was 29, and I told you it had a MAD of, and I'm just going to make this up, of 2. So we have a mean of 29, a MAD of 2. So within one MAD, how many data points are in that line plot within one MAD? So 29, if I go within one MAD, which is 2, I would go 2 this way, positive, and where's the other way do I go? Backwards, 2 this way. Chase, how many?
Or 5.
11. You're just counting the numbers. We need to not just count the numbers, but there's 11 between one MAD. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so those data points are all within one MAD of the mean. If I said 2 MADs, how many data points? All of them, right? That's where we get, 14? Okay, so it would be all of them because 2 MADs would bring me to 25 down here and all the way to 33 here. Because this is a 1 MAD and then a 2 MAD jump. Questions about that?
Why would we use the 2 MAD? I had no idea.
This is what I was supposed to teach you yesterday. Instead, I was at home herxing, my face was numb, and I was like, oh, brain fogged.
Hey, at least we all watched Bill Nye the Science.
Bill Nye the Science Guy is pretty awesome. So, your, whoops. So today, you're going to, what?
Yeah, he's really old though right now.
He is really old, but he's still,
He was on Dancing with the Stars.
how do you know this?
I watched it.
He's on Dancing with the Stars. Okay. So here we have. Yeah. Okay.
Where is this?
Okay. This is your sheet that I'm going to hand to you. It has your job today is you're going to have data for team 1, team 2, team 3, 4, 5. Bianca in your book, she has a strategy. You read her strategy and you do her strategy with each team. Okay, so you do it 6 times. Gianna also has a strategy, and you do her strategy with each team 6 times.
They're probably all gonna be
Okay.
super complicated.
They're not super complicated. Bianca's strategy is basically looking at the sums. Gianna's is calculating the mean, which obviously is pretty easy because you calculate the sums first. And then to find the mean is pretty easy. You take the sums, divide it. show your work for Jonah. Jonah has the most complicated because he's using the MAD. What you're going to do, Jonah, jeez, he's always the most complicated.
This is why we have no one needs
Wait. No one said they didn't like Jonah. No.
Wait, this is why we have no Jonas in our grade, because we kick them all out. They're always so complicated.
So here's the deal. When you get to Jonah and you finish and you got Bianca's strategy, you got Gianna's and you got Jonah's, and each time you calculate each strategy 6 times, you look at and you ask yourself, which strategy do you believe gives the best representation for these teams?
For which one is
So these teams, and you're going to read about it, your teams are fundraising. And these are fundraising sums. This is all on page 10. Yep. But the first thing you have to do,
Oh no.
I've done most of the work for you here. I've created your scales. I've even told you team 3 fundraising, team 4, team 5. You do have to, I want you to practice the line plots. The reason why is there were classes that had no idea what line plots were, so I figured we should probably recreate that instead of just give it to you.
Line plot is where you put the dot on the line.
Dot on line. Okay, today, this is your work. Hey guys, Tobin, your work for today is AL, BL, DL. I know, it's my cord. You do not have to do C. Okay? We'll talk about C on Monday. Okay. Any questions about what I just covered? It was pretty fast.
Wait, so the directions on that piece of paper say like calculate using Bianca's method or whatever. So like what are we calculating? Does it tell us?
Yeah, what page is it on?
It's on 11.
10 and 11.
What are we calculating?
You're calculating Bianca's strategy, which is sums. You're calculating,
So you just add them all up and then you do.
but you'll see. The idea around it is to go back to our learning target, which is when you have a data set, you make judgments about data. And these are methods that you use to make the judgments. Okay? Looking at data, and this is a story, remember Miss Harris? I was telling you about Miss Harris and her company. They use a lot of these strategies because they're effective in making better judgments about data. And that informs her business, makes her business perform better, gives them information so they can make appropriate changes. Mm-hmm. Questions?
What is her business? I painted her business.
All right. Okay. Get to work. Yeah. Juan's coming around. And I'm putting you to work today.
Let's go to the restaurant.
Yeah.